Okay, so here we are doing section 1.1 in our textbook, the 1983 textbook. All right, so we're going to start out, the first half of Algebra 2, Accelerated Algebra 2, is actually a review of Algebra 1. So we start out really, really easy. In fact, a lot of you will probably feel like this is maybe too slow. The way that I typically do notes is in Cornell note format. How many people are familiar with that? Okay, so you don't have to follow this format if you don't want to. The thing that's really neat about Cornell Notes is that you can use it as a study guide to help prepare you for group tests and all of that, but you don't have to follow it if you don't want to. Okay? Oh, that's another difference. Okay, so I know Mr. Humphreys does like a key term or a formula and then does some examples with it, right? And then moves on. Yeah, I do it differently. I do all key terms first, and then I go through all examples after that. Okay? So, Cornell Notes, the way that they work is you draw a line somewhere like a third of the way in on your paper. Again, you do not have to do this if you don't want to. And basically all key terms or directions for problems go on the left, and all definitions or solutions go on the right. And I'll show you how that can be helpful to you after we get some stuff on here. Okay, so variable. What's a variable? Yes, Jared, right?
Yeah. It's like anything that is unknown or can be changed, like often shown as a letter.
Good. Okay, so it is a letter to represent any number, correct? So letter to represent a number. Okay, good. See, starting out super easy. Okay, the second one, what do we have next? An algebraic expression. Okay, so an algebraic expression, can you guys see that okay? Okay, Jade?
Yeah, I have a question. So, what you're going to do is you're going to have the term and then define the term and then give examples after? Or?
Yes.
Okay.
Yeah, so we have, after this, we have one more key term, and then we're going to go through several examples.
Okay.
Yeah, you guys get it easy in the beginning. I don't know how, but Algebra 2, the regular Algebra 2, they get stuck with a lot of stuff in the beginning. You guys get it pretty easy. It's interesting. Okay, what is an algebraic expression? Lydia?
Is that when it's like there's a variable and it like an equal sign?
Ah, okay, good. So that's actually an algebraic equation. So, but an expression, the only difference between an algebraic equation and expression is that an equation has an equal sign and an expression does not. Okay, so it's a combination of variables and constants. That's about it. It's a combination of variables and constants. Oops, variables and constants. Okay, third thing is order of operations, third key term. Okay, anybody remember order of operations? Perfect, PEMDAS. I'm going to write this down here. P-E-M-D-A-S. All right, so what does the P stand for? You guys can all shout it out. What does it stand for? Parentheses. Okay, how about the E? Exponents. Okay, M? Multiplication or multiply. D? Divide or division. A? Addition. And we have subtraction last. Okay. So all we're doing is we're getting some practice with these kinds of things today. Should be very, very easy for all of us. Okay. Can I move this up? You guys good? All right, so let's do, now we're going into our examples. Again, I know I do it differently than Mr. Humphreys. Okay, so we are evaluating for x equals 3 and y equals 0.6. Sorry to throw the decimal in there right off of the bat. Shouldn't be too bad, though. Okay, so x over y minus xy, we are evaluating that. Okay, so Typically, when I do these, I put, so the problem is on the left, and then if there's work to be shown, I'll rewrite the problem on the right-hand side, and then fill it in with the solution afterwards. Again, that's if you're following the Cornell note thing. If you're not, just do it however you would like to do it. Okay, so what does it mean evaluate? Evaluate for x equals 3 and y equals 0.6. What does that mean? Jade.
Does it mean like put the numbers in and then figure out the answer?
Perfect. Put the numbers in and then see what it comes out to. So what am I substituting in for x?
3.
Okay, and what am I substituting in for y? 0.6. Okay, so 3, 0.6. On things like this, use your calculator. That's fine by me. I mean, I'm pretty strict about calculators, but when you're dealing with 3 divided by 0.6, I don't expect you all to work that out on your own. So 3 divided by 0.6, that comes out to 5. And 3 times 0.6 is 1.8. 5 minus 1.8? What's that? 3.2. Questions? Okay, do we want to do another one of these, or do we have the hang of this kind of problem? Good? Okay. So we start out very basic in this class. Okay. Okay, so yeah, so let me show you this. Okay, so with the Cornell Notes thing, if we wanted to, I know you all love to study, and more particularly love to study math. So with the Cornell Notes, on the left-hand side, you have a bunch of practice problems. We've only done one so far, but you can go through and like fold the paper in half, and you have a practice problem on the left, and if you've taken notes well, you have the full solution on the right-hand side to practice with. So that's the whole thing with the Cornell Notes. Okay. Does everybody have this? Can I take it away?
Yes.
Okay. All right. So let's move on. More evaluating of things. All right. So we have 16 divided by 4 plus 7. 16 divided by 4 plus 7. Okay. So everybody evaluate that right now on your paper. See what you come up with. 16 divided by 4 plus 7. Raise your hand when you have an answer. Okay. Somebody want to volunteer what the answer is that they got? Remind me of your name. What's your name? Nick. 11. Good. How'd you get 11? Good, right, perfect. So PEMDAS, so the first thing that we would do in here is what? Divide 16 divided by 4 is 4, and 4 plus 7 is 11. Questions? Okay, how about the next one? 6 squared, I'm going to have to write this down here because it's kind of long. 6 squared minus 3 times, in parentheses, 3 plus 5 divided by 3 squared minus 3. Write that over on the right-hand side. So we have 6 squared minus 3 times 3 plus 5 divided by 3 squared minus 3. Okay. So, can somebody start this problem out? If we're following the whole PEMDAS thing, what would we do first? Hannah? What's what? Parentheses, good. So we have 2 sets of parentheses here. We have this set of parentheses and we have that one. So 3 plus 5 is what? Okay, and then in the other one, 3 squared is 9, and 9 minus 3 is 6. Okay, good. Now what? What would we do next? Josephine, right? Okay, go ahead. So, I'm sorry, what's that? Good? Are you still going? I can't hear. Okay, so what? So, okay, so then what? Sure, go ahead. That's a divided sign, but okay, good. Good. So we have 36 minus 24 divided by 6. What next? Jared? Is that right? Okay, good.
Divide 24 by 6 and get 4.
Good. And you get what? 32. Good. So I will say this. In Algebra 2, in Accelerated Algebra 2, this is the kind of problem that stumps people all the time. So you guys can do these crazy levels of math, and then when it comes down to something like this, people forget PEMDAS all the time. So make sure that you're really, really good with that. Okay, questions? Okay. Next, find x. Am I going too slow? Too fast? Okay. Okay. 9 squared equals x. This is not a trick question. I know it might look like one, but it's not. What is 9 squared? See how easy we start out? Super easy. Okay. X to the third power equals 27. X to the third power equals 27. Okay. So we're looking for a number. What is well, okay, let me ask this. Does anyone have an idea about what x would be in this problem? Is it Stephanie? What is it? How'd you get that? How'd you know to multiply it 3 times? Good. So x to the third power represents a number that you multiply by itself 3 times to get 27. The number that you multiply by itself 3 times to get 27 is 3. Okay. We have 2 more examples and then we are finito for the day. Yay, very exciting. Okay, use this formula to find D. Make sure you all can see that. To find D for t equals 3. Okay, and the formula that we're given, that got really dark, how weird. Okay, the formula that we're given is D equals 96t minus 16t squared. And we want to use that to find D when t is 3. Okay, so we have D equals 96t minus 16t squared. So, in looking at this problem, anybody have an idea about how we might approach this? So raise your hand if you have some idea about how to approach this problem. Okay, Ashley? Good. Plug in the 3 where there's a t, and then go for it. So we get 96 times 3, it's 288. 3 squared is 9, and 9 times 16 is 144. So we get 144. All right, how are we doing on questions? Pretty straightforward so far? Okay. All right, last problem. Anybody still using this? Can I take it away? Everybody's done? Okay. All right, last problem. Find A for the given values. So find A for the given values of I1. Nope, not I1, sorry, just I. B and N using the following formula. Okay. So the formula is A equals 72I. How many people have their calculators already? Okay, go ahead and get them out for this problem. Over 3B times n plus 1 plus I times n plus 1. So that's all in the denominator. Okay, so we're finding A, using this formula, we're finding A for certain values for I, B, and N. Okay, and the B that we are given is $400. The I that we're given is $80. The N is 24. Okay, so this is an interest type of an equation. Yes?
I have a question.
Sure.
What's the last letter?
This one?
Yeah.
That's n plus 1. Let me go ahead and rewrite this up here. A equals 72I over 3B times n plus 1 plus I plus n plus 1. Okay, so who can start me out here? What am I doing in this problem? Jade.
Sorry, what question is that? 24 for n. Okay.
Yes.
And then so you fill in variables, so 72.
Good.
And then, 3 times 400.
Good.
Parentheses, 24 plus 1.
Uh-huh.
Oh, yeah, that's it. Okay. And then plus 80.
Uh-huh.
Parentheses, I meant 24 plus 1.
Good. Sorry about that, you guys. It's kind of off the page. Whoops. Can you see that? That's a little hard to see. Sorry about that. But so when you plug this in, n is 24, so it's 80 for I, right here, 24 plus 1. Okay. So going through and simplifying this. Are we all good on actually simplifying this? Can I just tell you what it comes out to? Yeah? Okay. Comes out to 0.18. So you're just, again, following order of operations. You're going to do parentheses, then there are no exponents, but multiplication, all of that. Okay? Any questions on this? Okay. We are done. So let me put the homework up. So we have homework 1. It's page 3, written exercises. That's what WE stands for. So this is a huge thing. In your textbook, the first set of problems that you will see says classroom exercises. A lot of people will accidentally do those. Don't do that. Okay, move to the ones that say written exercises. That's what the WE is for. It's numbers 4 through 56, 4n. So 4n, that means multiples of 4. So 4, 8, 12, 16, 20, all the way to 56. Okay? So that is due tomorrow. Any questions? All right, so everybody go and get out a book.